Hello, welcome to this tutorial on how to get a Kinect set up in a C++ project and get some basic information from it. There will be three things you need for this tutorial. One, a Kinect, otherwise, well, you can't test your code. You need the Kinect 2.0 SDK. Don't download the 1.0 or 1.8 or whatever. Download the 2.0 SDK and a C++ compiler. I'll be using Visual Studio 2015 for this tutorial, and a different version of Visual Studio should be fine. You should be able to follow along with the whole adding the library to your project part. The whole code part will be the same for any compiler you have. So step one, download the SDK. You can just download it from Microsoft.com. If you simply Google Kinect to SDK, first link should be the right one. The page looks a bit like this. The file you get when downloading it is an exe. Just open it, hit next a bunch of times, should be installed. After that, the first thing we're going to do is test if the Kinect actually works before we write any code. Otherwise, we might be writing fine code and it will give us a bunch of errors because the Kinect isn't even recognized by your computer. So luckily, the Kinect SDK comes with this great application called Kinect Studio. If you have your Kinect connected, you just go to this top left button, you press it, you wait a little while, and it should already give you information. This is a color map of the depth. Then there's also this cool 3D view of me. Hello. If this doesn't work, you should first troubleshoot why your Kinect doesn't work before continuing following this tutorial. So for this tutorial, I wrote a small testing application where we can just play around with some code, put some stuff on the screen. It's really basic. It's just a window with a console window. We have direct access to the pixels. It's just an array of pixels gets uploaded to the window. Very simple. I added some defines for changing the size of the screen. Added some type defs for explicit sizes. A little save release function for all the I call them Microsoft objects, where you don't call delete but release. And what this basically does, checks if it's null. If it's not null, release it and set it to null. We have an app class. It has three important functions in it: tick and shutdown. In it is called once to initialize your application. Tick will be called every frame, and shutdown will be called when the application closes to clean up any allocated resources. So let's go add the Kinect SDK to our project. We just simply go to our project, right click, go to properties. Under C/C++, go to general. Under add additional include directories, edit these. We add a new thing. If you open the macros list, you should be able to find Kinect SDK 20_dir. If that's not there, just restart Visual Studio because it's an environment variable and it only loads environment variables when Visual Studio opens. So we can just add that, Kinect SDK 20_dir, and then we want the include folder. Actually, have that folder right here. Here's the include folder with a bunch of header files. Now we've done this, we can go and add Kinect header files to our project. There's one more step. We also have to link the Kinect to it. So we just basically do the same thing again, but for the lib folder. Let's see, I always forget what the exact name is. Can't even remember it for 5 seconds. Kinect SDK 20 there and then lib backslash x86. Since we're on, I'm compiling for 32-bit. Right here you can see lib x86, and there are the lib files. Now it knows where to find the lib files. Now we have to add the actual lib file, which is called kinect20.lib. Kinect20.lib. Hit apply, and it should be all added. Let's include the Kinect header file. There's only one header file for the Kinect. It's Kinect.h with a capital K, which doesn't really matter on Windows anyway. It's just test to see if the program still runs, just in case we might have broken something. Everything seems fine. So the first thing we need to do is get a pointer to the Kinect sensor, and the pointer will be of type iConnect sensor. I'll just call it m_sensor. And then in the init function, I'll get the sensor. The function is called get default Kinect sensor. We pass the address to the pointer we want to be set, which is mSensor. And this function returns an H result. So HR equals, let's add some error checking. We'll just exit with 10. We'll print something. Fail to find the Kinect sensor. And then in shutdown, what we want to do is save release mSensor. One thing I forgot is to initialize the pointer to a null pointer, just in case something goes weird, and you never know, it's just best to set it to a null pointer. Let's check and see that the application runs. It still works. Oh, everything seems fine. There's one interesting thing about this function. If there's no Kinect connected, it will still just pause fine. It won't give you any error. So that's a bit odd. Actually, not any of the initialization functions will give you any error. Only when you're actually trying to get the data from the Kinect, it will start giving you weird errors. Okay, so now we have our Kinect sensor. Let's get some more stuff from that sensor. So what we want is, first I'm just going to try and get the depth data from the sensor. We'll use get depth frame source, which asks for a pointer to a depth frame source. I'll just call it depth frame source. And let's also get the result. Add a little error message just in case it breaks, and let's just exit with code 10 if it breaks. So now we have the depth frame source. What we need now is a depth frame reader. After we have the reader, we can actually throw away the depth frame source because we don't need it anymore. The depth frame reader will need for the whole duration of the whole lifetime of the program, so we'll add it as a member variable. Depth frame reader. Reader is null pointer. We can just simply say depth frame source open reader. Error checking. Failed to open the depth frame reader. exit with code 10. This opens a reader. This structure is kind of weird, I have to say myself. With any kind of data you want from the Kinect, you first open a frame source and then a reader, frame reader, and you use the frame reader to get the actual data. Let's just add some comments. Get the Kinect sensor, get the depth frame source, get the depth frame reader. After we've done that, we can we'll get a depth frame. We'll try and get the depth frame every frame tick, so basically every frame of the application. We need new H result. We can just simply say depth frame reader acquire latest frame. We'll need a depth frame. Frame. Let's check for HR equals if field HR return. The Kinect won't be able to give us as many frames as the program is requesting, because the program runs way faster than the Kinect. So we'll just return error code, and if we get an error code, we simply return. Also, one thing to note is that when asking data from the Kinect, the first few frames will just be will fill, and then it will start getting actually giving you the data. The Kinect 2 gives you a depth buffer that's 512 by 424 pixels. For this demo, for this tutorial, we'll just hard code that in. There is a way to get the dimensions at runtime, and just in case you have a different type of Kinect. For now, we're not going to worry about that. The depth information will be an array of 16-bit unsigned integers. So we'll just create an array here, uint16, so it's 16-bit unsigned integer. I'll just call it depth buffer and initialize it to null. Let's just allocate that here. Oops, I forgot to make this a pointer. Depth buffer equals new uint16 512 times 424. So now we have a depth buffer. Oops, I actually forgot to clean up the frames, depth frame source and depth frame reader. So clean up the depth frame source here, since we don't need it after initialization anymore. And I'll clean up the depth frame reader here. And I'll also delete the depth buffer. So now that we have our depth frame and we have a buffer to put the depth data in, we can simply call depth frame. Oh, hold on. After the error check, depth frame. What's it called again? Copy frame data to array. And it wants to know the capacity of the array, which will be 512 times 44, since we're just hard coding it in right now, just for testing purposes. And a pointer to the array in which it's going to put all the data, which will be depth buffer. And once we've done that, we have to release the depth frame. If we don't do that, it will get the first frame and then it will fill consistently. so save release depth frame. Let's run the application, see if we forgot anything. It should be working fine. Okay, at least it's not crashing. Let's actually put a print statement at the copying so we know it reaches this point. Copying data. It's not reaching that because I think I forgot a step. Yes, I forgot to open the sensor. For some reason, you have to call open. I don't know why. You just have to. Now it should be working. Yes, there we go. It's copying data into our array. There's one more thing that I didn't do, and that's check to see if the copying actually worked. So we'll just get our H result. Any function in the Kinect API, at least I think all functions return an H result with an error or an OK or a warning or whatever. And then we want to return. I want to print oh no, something went wrong while copying, just to make sure it works. And we also want to release it if we take this branch. Have it load. You can already see that it takes a while for it to basically start up. So the copying is going fine because this oh no, something went wrong while copying is not showing up. So now we have our depth data in an array. Let's actually visualize the depth data by putting it on the screen. Since the size of the depth buffer is 512 by 424, we'll just make the window size that. 4, let's run it. Okay, now a window of the correct size. And now let's copy all the depth data to the screen. Copy depth data to the screen. I'll just use a quick little for loop. Oh, I actually can do this. Alright. Then we have depth buffer I. So we have our depth value, and we'll copy that into our pixel buffer. Yeah, that should work. And we'll see a bunch of weird stuff. It's all blue and stuff. You know what? Let's actually make this grayscale so you can see it a bit better. We'll do. Let me just hack this in real quick. I want to say A. So basically what I'm doing is I'm only taking the last byte, the rightmost byte of the depth data, and I'm putting that for the red, green, and blue value of the pixel. And now we get this nice visualization. Whenever you see it going from light to dark, that's basically when it wraps around. So basically when you see my hand like this, you can see it wrap around because it doesn't fit into a single byte. The actual depth data is simply millimeters distance from the camera. The camera has some limitations. It can't measure anything closer than half a meter. So if I take my hand, put it really close, you'll see it become all black. And it can't measure anything further away than, I think, 8 meters. Any value, if it failed to read, will just simply be 0. So that's that for getting the depth data. It's actually pretty simple. This method uses a polling technique where we just check every frame. There's also a way to use the Windows event system to just get an event every time a new frame has been recorded. I'm not going to do that for this tutorial. I just want to show you some other bits we can do. Yes, what I'm going to show you is how to get actual information of the frame, like what is the size going to be, how many bits per pixel, all that kind of stuff. The Kinect SDK puts this in a so-called frame description, which you can get from the frame source. So we had the sensor, then a frame source, and then a frame reader. We use the sensor to get a frame source, which you use to get a frame reader, which you use to get a frame. The frame information you get from the frame source, which is a bit odd. I don't really like the way they set it up, but that's just how it is. So let's add that in. We'll just get the frame description at init time, since it's not going to change anyway. So depth frame source gets frame description. We need a pointer. Excuse me. Yeah, well, there's a bunch of stuff you can get from it. You get the bytes per pixel, diagonal field of view, the height, horizontal field of view, length in pixels, vertical field of view, and the width. We're interested in is basically just width and height. Get width. Let's just make these member variables from m depth width and m height. These functions actually, These functions actually also can return an error. For this tutorial, I'm just going to ignore that error since the chance of it happening is really, really small anyway. I don't even know when that error would occur, maybe if the Kinect is disconnected while calling that code, but I'm not going to worry about it. So that we have that information, we can actually dynamically allocate our depth buffer. And in here we can actually loop over it like this. And in here we want to say depth width times depth height. Let's put that on a new line. Let's see if it works. And everything still works fine. One important thing I forgot to mention when copying data from the depth frame to an array is that this function, when it takes a capacity, that's capacity in elements, not in bytes. So the depth frame has unsigned shorts or unsigned 16-bit integers. So the actual size of this buffer is going to be twice as big than what you pass it. It wants the number of elements, so the number of unsigned 16-bit integers. Now that we have added depth, let's also add some color, which is another big thing we can do with it. Getting color or getting any information from Kinect is actually really similar as to getting the depth. It's basically all the same. So what we have is, as a member variable, we again want instead of a depth frame reader, we want a color frame reader. And to get a color frame reader, we will first need a color frame source. Let's just add null to the bottom. mSensor get color frame source. I color frame source. Color frame source. Else if field HR was print a message, failed to get color frame source, and exit with my magical exit code. Now we have the color frame source. We need to get the color frame reader. Color frame source get open reader. Color frame reader. Let's get the result from that. If field HR print an error message. Field to open color frame reader and exit with our magic exit code. After we got our color frame reader, we can just we can release our color frame source since we don't need it anymore. Excuse me. Now we've done that, we can get the data from our we can get the actual color data. So let's just keep this all as, I'm just going to comment this as depth stuff, and we'll just do color stuff here. Oh, I don't want to have here, just color stuff. What we first need is a color frame. It's basically the same as the depth frame code. Color frame reader, acquire latest frame. If field HR return. Now there's one thing that's a bit different with the color frame, and that is, well, it's not really different, it's just an extra feature. It can copy, when you copy the data into the array, it will convert it to a format that you want. The capacity of the array I want to put it in is 1920 times 1080 times 4, since it expects an array of bytes, and it basically sees it as an array of constantly ARGB, ARGB, ARGB. So it sees it as individual bytes, so it wants the number of elements, which is a byte, so it's 1920 by 1080 times 4. 1920 by 1080, I already know from this, the particular Kinect I'm using. If you were actually use this in a real world application, you would first get the frame description, just like we saw with reading the depth, and then actually dynamically allocating a buffer. For this tutorial, I'm not going to do that. Actually forgot to allocate a buffer for our color. So just create a new thing, make it unsigned 32-bit integers, because that's also the format our pixel buffer is in. Doesn't really matter if you use bytes or unsigned 32-bit integers. Let's just call it color buffer, set it to null, and then in it we'll allocate it new UN32 2020 times 1080. So we'll pass it to the color buffer, and the color image format we want to be in is either BGRA ARGB. I can never remember which one, so I'll just try both. I have to cast this to a byte pointer array, byte pointer buffer array thing. Check if it's succeeded. After this, we want to release the frame. If you don't release the frame, again, the same with the depth frame, it just it will read the first frame fine, and then the second frame it will just say, no, you did something wrong. Let's just clean up everything we did now. With the color buffer, and let's save release the color frame reader. Let's resize the window to 1920 by 1080, and we'll just comment. I'll just comment this out for now. And I equals 0, I is less than 20 times 1080. It's basically just copy the color buffer onto the pixel buffer that gets pushed to the window. And pixel buffer I equals color m color buffer I. And when we run it, we should be able to get the color data from the Kinect. Then run for the first few frames. And there you can see me twice. Hello from camera 1 and Kinect. So our application is working. Blah, blah, blah. Again, getting color is really similar to getting depth. Getting body indices is basically also the same. It's all the same. It's basically any data you get from it is done in this way. There's one other thing, and that's has to do with the way the Kinect is built. Let me just grab the Kinect. What you basically see is you have your main camera here. This is the color camera, and then there's a depth camera in the center. So anything it records isn't perfectly aligned. So let's say you want to build a point cloud using the depth data, like in this Kinect Studio sample. So let's say we want to build this, and we would like to add color to this this cool 3D voxel thing. Since the cameras are at different positions, it's not as simple as just copy pasting the texture over it, because as depth changes, the alignment basically changes. Luckily, the Kinect SDK has a solution for this with the coordinate mapper. And what the coordinate mapper basically does is you can give it an array of depth values, and it will give you back an array of the texture coordinates for every depth value. So let's do that. I'll just get rid of this. Let's get rid of this, and let's make our window small again. Well, actually, let's keep copying the depth data, but just make our window small. See if it works. Yeah, we got our depth data back. My computer is lagging a bit right now, but that's because I'm recording it. Yeah, let's get the coordinate mapper. So I'll just add this new member variable. I coordinate mapper and coordinate mapper isn't no pointer. I can type. We can get the coordinate mapper from the sensor. This got a bit messy, so I'll just clean this up first a bit. This is get frames, frame source, get depth frame description. Release the depth frame source, allocate depth buffer, get color frame source, get color frame reader, and please the color frame source. Okay, now that this is a bit more clear and commented and stuff. Oh, and allocate color buffer. So let's get back to the coordinate mapper. To get the coordinate mapper, it's basically the same as getting a frame source. We just say m sensor and get coordinate mapper, and we pass a pointer to a coordinate mapper. Let's get the result. If build hr printf failed to get coordinate mapper oh no's and exit with our magic code, then comments get the coordinate mapper. Let's test if it works. We just drink some more water. And everything seems to work fine. Now that we have our coordinate mapper, let's actually get the mapped coordinates. For this tutorial, I'm just mapping the color on the depth buffer. You can do a whole lot more with it. If you really want to know it, just play around with it. The functions are pretty straightforward. So what you want to do is map color frame to depth space, I think, or was the other one? Map depth frame to camera space. Yes, this is the one. We want to map the depth frame to, no, not camera space, color space. To color space, that's the one. So basically, we give it the size of our depth map, which is depth width, depth height, and our actual depth buffer. And then what it wants is a excuse me, is an array of color space points and the number of color space points we're passing. Color space point is nothing more than a two-dimensional vector, basically just two floats, it's an x and a y. I'll have to allocate this buffer first. It will be the same size as the actual depth buffer. So I'll just add another memory variable, color space points, color. I'll just call it m color space points, just for simplicity's sake. Set it to a null pointer. Allocated during init. Color space points equals new color space point. That's depth width times depth height. If you actually look at the definition of a color space point, if Visual Studio wants to, I mean, you can see it's just a struct with an x and a y, two floats, really simple. Allocate a buffer of color space points. So we basically just want to pass that array. The dimensions are the same, depth width times depth height, and that's color space points. Let's add error checking, see if it fills. If failed, hr, we'll just print something. Oh no, failed to map the depth frame to color space, and then return. So let's just check to see if it works. And if we get a depth, we get our cool depth info. It's not printing, so that means it's working correctly. So now let's change this bit of code. So we don't want to draw our depth value anymore. We want to draw the color of each depth value. Excuse me again. Let's see. Color space points. So we'll get the color space points. So color space points. I'll just call it CSP. And CSP has an X and a Y. And this X and Y is not in normalized UV space. It's basically already in texture space. So the minimum value will be 0, and on the U axis, the minimum value will be 0, and the maximum value will be the width of the texture. And on the Y axis, the minimum value will be 0, and the highest value will be the height of the texture. So basically, what I'm trying to say is, it's not normalized. It's already multiplied by the width and height of the color map. It gives you floats, so you can actually do cool stuff like linear interpolation between pixels and get better values. For now, we'll just do nearest. I'll just round them down and get whatever color is there. So I'll just say integer x equals csp.x, cast it to an int, and we'll have int iy is int csp.y. Some some depth, some part of the depth map won't have any color space. Okay, let me put it like this. Some of the stuff we record using the depth camera isn't being recorded by the color camera. So not every color space point is going to give us a value that's a valid point in our color map. So what I'm going to do is also add an if statement to see if the coordinate is inside the color map. So it's really simple. If it's greater or equal to 0 and it's less than 1920, so if it's in range on the horizontal axis, and we want to do basically the same for the y-axis, 180. Then we want to say pixel buffer I equals color buffer ix times iy times 1920, basic, just using a pitch to move. Oh, it's actually ix plus iy, and that should give us the mapped color, basically our color map mapped onto our depth map. For debugging, we'll just make it red if it's outside of the texture. So let's see, it's loading, it's loading, it's loading. There we go. So as you can see, you have these edges around here where the color camera can't record any of it, and you have these bits around me, these red bits, which is bits that the depth camera couldn't read, so we also can't map our color data on that. I also get this weird effect where I have a finger extra, which is really weird. It's not like the greatest thing, but it's the closest thing you'll get to. I heard there are also some other methods, but this is just the easiest way, just get something going. So let's do a quick little recap. What we learned in this tutorial was how to add the Kinect SDK to our tutorial, how we got depth information from the Kinect, how to get the actual information of a frame from the Kinect, how to get color data from the Kinect, and how to map the depth data the color data onto the depth data. There's a ton more stuff you can do with it, but as soon as you really understand how this works, the rest should be pretty easy to understand since it's all very similar. Well, thank you for watching. I hope you learned a bit more about the Kinect, and